In this video, we will understand what are exponential and logarithmic limits. Exponential functions are of the type fx equals e to the power x or gx equals a to the power x, where e is an irrational number whose approximate value is 2.7182 and a is any constant. Log x to the base e is known as natural logarithm. It is sometimes written as ln x or just log x for simplicity. Since e and log x to the base e have interrelationships, we will consider their limits together. Let's get acquainted with a formula. Limit a to the power x minus 1 over x as x approaches 0 is log a, where a should be positive and a should not be 1. Let's use this formula to solve limit 3 to the power x minus 5 to the power x over x as x approaches 0. Now we have to rearrange these terms in this form. So we will write in the next step as 3 to the power x minus 1 minus 5 to the power x minus 1. Here 3 to the power x minus 1 is of this form and 5 to the power x minus 1 is of this form. Now let us see whether the changes that we have made in the numerator here do not change the original value in the numerator. See, minus 1. This minus into minus will become plus. Minus 1 plus 1 will become 0 and 3x minus 5x will remain, which is the original numerator. So the changes that we have made do not change the original numerator here. In the next step, we will divide each of these terms by x and write two separate limits. See, first limit is 3 to the power x minus 1 over x and second 5 to the power x minus 1 over x as x approaches 0. Now according to this formula, the first limit will be log 3 because in this case a is 3, and the second limit will be log 5 because here a is 5. Now to solve further, we will use the rule of logarithm, which says log a minus log b equals log a over b. So accordingly, the final answer will be log 3 over 5. Solve limit 9 to the power x minus 5 to the power x over 4 to the power x minus 1 as x approaches 0. If we want to use the formula, this about which we have seen earlier, we have to rearrange the terms in the numerator in this form. Therefore, we will write the next step as 9 to the power x minus 1 minus 5 to the power x minus 1. Here, minus into minus 1 will be plus 1, plus 1 minus 1 will be 0, and 9 to the power x minus 5 to the power x will remain, which is same as the original numerator. Now, there are two terms in the numerator and one term in the denominator which are in this form, and we need x below each of these terms. Therefore, we will divide numerator and denominator by x and show that in the next step. Now we have these three terms which are in this form. So we will write separate limits for each of these terms, and our next step becomes now, according to this formula, the limit of this function will be log 9, limit of this function will be log 5, and limit of this function will be log 4. This we will write in our next step. See here, for this we have written log 9, for this we have written log 5, and for this we have written log 4. Now ln 9 is same as log 9 to the base e. In the next step, we will write 1 over ln 4 into bracket ln 9 minus ln 5. Here we will use the rule of log. Log a minus log b equals log a over b for this bracket, and our answer will be 1 over log 4 into ln 9 over 5. Solve limit 15 to the power x minus 5 to the power x minus 3 to the power x plus 1 divided by x sin x as x approaches 0. Here, first we will write 15 to the power x as 5 to the power x into 3 to the power x, because these two factors appear over here. So in the next step we will write this change. Now here in the first two terms we can take 5 to the power x common, and in the last two terms we can take minus 1 common and write the next step. When we take minus 1 common, here plus 1 becomes minus 1, because minus into minus will become plus. Now here, from the two terms in the numerator, we will take 3 to the power x minus 1 common and write the two factors as the first factor will be the common factor, which is 3 to the power x minus 1, and the second factor will be what remains, that is 5 to the power x minus 1. Now, in order to apply this formula, we need x below each of these factors in the numerator. For that, we will divide both numerator and denominator by x square. So, we write here we will distribute this x square as one x below this factor and another x below this factor, and in the denominator this x will get cancelled with 1x in x square, and what remains is sin x over x. So in the next step we will write These are the separate limits for each of these. See, 3 to the power x minus 1 over x, 5 to the power x minus 1 over x, and in the denominator sin x over x. Now we will apply the formula which we have learned, a to the power x minus 1 over x as x approaches 0 is log a. For this limit, we can write log 3. For this limit, we can write log 5, and for this limit, we will write 1 because we know limit of sin x over x as x approaches 0 is 1. And finally, the answer will be log 3 multiplied by log 5. Solve limit e to the power x plus e to the power minus x minus 2 divided by x tan x as x approaches 0. Here, first we will simplify the numerator. In the numerator, we will write e to the power minus x as 1 over e to the power x. Now here, e to the power x is the common denominator. So we will multiply each term here by e to the power x. So e to the power x multiplied by e to the power x will be e to the power 2x. E to the power x multiplied by 1 over e to the power x will be 1. And e to the power x multiplied by minus 2 will be minus 2 e to the power x. Now we will write this numerator as e to the power x whole square minus 2 e to the power x plus 1 divided by e to the power x. Now if you observe carefully, you will find that this expression is a perfect square expression. According to the identity that we have, a squared minus 2ab plus b square is a perfect square expression because we can write it as a minus b whole square, where a is square root of a square, b is square root of b square, and the minus sign is the minus sign of the middle term. So we will apply this identity over here and write square root of e to the power x square will be e to the power x, square root of 1 will be 1, and the sign of the middle term minus will be minus here. So the whole numerator will be e to the power x minus 1 whole square divided by e to the power x. Now this value we will use in the next step directly. See here, we have written the numerator as what we have found out here. In the next step, we will write this e to the power x along with x tan x. So it will be here in the numerator we can apply the formula that we know, limit e to the power x minus 1 over x as x approaches 0 equals log e to the base e, which is 1. For that we need x square below e to the power x minus 1 whole square. Therefore we will divide both numerator and denominator by x square. So the next step becomes see, we have divided by x square in the numerator and denominator. In the next step we will write in the numerator e to the power x minus 1 over x whole square. In the denominator, this x will get cancelled with 1x from x square and it will be tan x over x. Now we will write separate limits for this one, and this one. So in the next step, we have three limits. First limit, second limit, and third limit. Now the value of this limit according to this formula will be ln e or 1. The value of this limit can be found out by putting x equals 0, so it will be e to the power 0, and this limit can be found by the limit formula that we know, tan x over x as x approaches 0 is 1. So in the next step, we will write for this limit ln e whole square, for this limit e to the power 0, and for this limit 1. Now ln e is nothing but 1. Therefore, it will be 1 squared. E to the power 0 will be 1 multiplied by 1. So finally, the answer will be 1. Let us get acquainted with another formula, which is limit 1 plus x to the power 1 over x as x approaches 0 equals e. Here, the terms in the bracket are of the form 1 plus term in x, and the bracket is raised to the power which is reciprocal of the term in x. Let us solve one limit problem based on this formula. Solve limit 1 minus 3x over 5 to the power 1 over x as x approaches 0. First, we will write the terms in the square bracket in the form 1 plus x. So we will write 1 plus minus 3x over 5 square bracket raised to 1 over x. Now, according to this formula, we must raise the square bracket to the power which is reciprocal of this term. So in the next step, we will write here. You will observe that we have raised this square bracket to the power minus 5 over 3x, which is the reciprocal of minus 3x over 5. Now we have changed the power, and we must bring the changed power back to the original power. Therefore, we will raise the bigger curly bracket to the power minus 3 over 5. Now where does this minus 3 over 5 come from? It comes from the product of these two terms, minus 3x over 5 multiplied by 1 over x. See here, minus 3x over 5 multiplied by 1 over x. X will get cancelled from numerator and denominator, and what is left is minus 3 over 5. Now this minus 3 over 5 is the power given to the bigger curly bracket. Now, to ensure that our powers are correct, we will do the calculations. See here, this 5 will get cancelled with this 5, this 3 will get cancelled with this 3, minus into minus will be plus, and what is left here is 1 over x, which is the original power. So we have made the change and we have compensated it here. Now, limit of The function in the curly bracket according to this formula will be e, and that e should be raised to the power minus 3 over 5. So our answer will be e raised to the power minus 3 over 5. Solve limit 1 minus x divided by 1 plus x to the power 2 over x as x approaches 0. First, we will write the power 2 over x as 1 over x square. In the next step, we will distribute this power separately to the numerator and denominator. In the next step, we will write this 1 minus x as 1 plus minus x and write two separate limits for numerator and denominator. See here, 1 minus x is written as 1 plus minus x. In the next step, we will raise this square bracket to the power minus 1 over x. See here, we have raised this square bracket to the power minus 1 over x, which is the reciprocal of minus x. In the next step, we will write the limits in the curly bracket and limits in the curly bracket from numerator and denominator according to the formula that we have. Limit 1 plus x to the power 1 over x as x approaches 0 is e. Therefore, the limit in the curly bracket in the numerator will be e, and the limit in the curly bracket in the denominator will also be e, but each of them will be raised to the power minus 2 and 2 respectively. So, our next step will be e to the power minus 2 and e square, which is this 2. Now, the final answer will be e to the power minus 4. Let us get acquainted with another limit formula, which is limit of log 1 plus x over x as x approaches 0 equals 1. Now let us solve this limit and see how this works out to be 1. So, limit log 1 plus x over x as x approaches 0. We will write log 1 plus x over x as 1 over x log 1 plus x. Now, according to the log rule, which says n log m equals log m to the base n, which means the leading coefficient of log, which is n, goes as the power of m here. So in the next step, we will write one plus x to the power 1 over x. Now, at this stage, let us understand one thing, that limit of log is same as log of limit. So therefore, in the next step, we will write log of this limit in the curly bracket. Now, the value of the limit in the curly bracket we know, which is e. Therefore, in the next step, we write log e to the base e. which will be 1, because log of a positive number to the same base is 1. Therefore, limit log 1 plus x over x as x approaches 0 is 1. Now let us solve one limit problem based on this formula. Solve limit 7 to the power x minus 1 whole square divided by x log 1 plus x as x approaches 0. Here we observe that we need x square below the term in the numerator. Therefore, we will divide both numerator and denominator by x square. See, numerator divided by x square, denominator divided by x square. Next, we will write the numerator and denominator as separate limits in the next step. Here, this x gets cancelled with 1x from x square, and we get log 1 plus x over x. Now we will write separate limits for numerator and denominator. Now the value of the limits will be log 7 whole square divided by 1. Now this log 7 whole square will be, according to the formula, limit a to the power x minus 1 over x as x approaches 0 equals log a, and the limit in the denominator will be according to limit log 1 plus x over x as x approaches 0 equals 1. Therefore, finally we get log 7 whole square as the final answer. So this is all about exponential and logarithmic limits. Hope you liked my video. If you did, please click like and share this video to the needy, and please subscribe our channel. Thanks for watching and have a nice day ahead.